Okay, in this tutorial I'm going to give you a quick primer on how to use the electronic workbench. Okay, because that's just what we're going to be using to facilitate our practicals on SOE 208. Okay, so if you have downloaded it, or just like I have actually sent it to you, I sent it as a zip file. Look at it here, version 5.12. When you click it this way, you open it up. That's when you have unzipped it. You are going to find three files. One, you have the tutorial that tells you how to use it, but I'm just going to give you a quick primer on it so that you get up and running with it quickly. Now, when you double click this, you are going to go some extra steps that is designated by it. And then there's nothing much that you're going to be seeing along the way. Just click next, and so on and so forth until you have the software installed. Okay, now I've already installed it, and let me call it up. Now when you call it up, you are going to have something like this. Let me quickly enlarge it. Let me quickly let me see how to space it out. Okay, so when you have it this way, you are seeing the menu bar, and quickly this please talks about the component packages that we are usually going to be using to execute our project. Okay, now because we are dealing with mostly digital logic circuits, all of our components are mostly going to be found in this place. But because yes, all of our components are mostly going to be found in this place, but that does not mean because there are digital ICs like here, you have a series of digital ICs that you can find here. So if I want this, I can just click. When you click it, you hold your mouse and then you drag it to the point you want it to be in on your screen. Then depending on when you look at it, you see the component, the kind of component that are supposed to be inside of this IC. Okay, now you can have quad 2 inputs and NAND gate. Okay, now what it means is that we have 2 inputs NAND gates into 4 in this IC, and so on and so forth. This one is NOR gate, and this one is quad 2 inputs NAND gate, and so on and so forth. You have inverter. So if peradventure we just want this one, I can just click accept. That's the one I want, and I've told you how to actually look at the numbering of this. Now when you keep your normal IC like this, you are going to find a notch here or something like a 0 here, and then the counting is going to start from this place to this place. Okay, now I'm not going to be using ICs for this. I'm not going to be using ICs, but what I'm trying to tell you is that it is possible that you can as well use IC to achieve whatever you want to achieve. Okay, so we have 1 input, 2 inputs, you have output here, you have another input, you have another input, you have an output, and this is the ground. And this one, you also have 1 input, 2 inputs, you have an output here, and so on and so forth. Okay, now we're not going to be using IC like I said. We're going to be coding, or rather using the fundamental logics from scratch. So if I want, I can just right click this and then click delete to remove it from my screen. Okay, now when you want to, let's quickly begin to look at this. I want this. When I click it, I'll just drag it. Okay, I drag it to this place. Okay, because what I have here is actually an AND gate. You look at it as it is labeled. You have an OR gate, you have a NAND gate, a NOR gate, a NOT gate, exclusive OR gate, exclusive NOT gate, and buffer. Okay, now we're going to be looking at the basic gates. You already know the properties of those gates because we already have our truth table that we use to look at what is happening when we have a particular input into this gate. And now in this device, rather in this particular system, we are looking at the truth table, right? Now the truth table of AND gate says that this input and this input is supposed to be 1 before we can get an output here, okay? But if we have an OR gate like this, the rule of OR says that either of these or both of them can be high for the output to be 0, okay? Now I'm going to be testing these different things, okay? Now when you want to have the property of this component changed, you can right click on it and then you look at components. Now when you look at components, we by default have 2 input gates here now, but you can change it by looking at the number of gates, number of inputs that you can find here, and then you say let the number of inputs be 4, and when you say okay, you now have 4 inputs AND gates, okay? When you look down here, when you highlight it and look down, you are going to see where it is written 4 input AND gate, okay? But for the purpose of this, let's stick to our 2 input gates and so on and so forth, so we can have a little let's just have a little practical on this. Now for us to see the output, there are things, display units that we can find here. So this is a display block. So when you click on it, everything that you're going to be seeing here are the things that you can use for display. Now for instance, we are going to be using this probe, okay, for display, and when I bring it, I place it where I want it to be, and if I want to rotate this, I can right click it and then rotate it the way I want it. I can rotate it this way and then rotate it again, and it aligns with this one, okay? Now but you can as well look at the flip horizontal and flip vertical depending on what you want to achieve, okay? So that may be a quicker way for you to organize this. Now another thing I'm going to, when you hover over this, is going to tell you what output device it is. This one is voltmeter, this one is ammeter, this one is a bulb, and so on and so forth. 7-segment display. We are not going to be dealing with electronics in a very large scale, right? All right, we are just looking at digital electronics, okay? And when we talk about digital systems, we are talking about system that makes use of either 0 or 1, okay? Now I already have my input here, my gate here, and I'm already having my this probe here, okay? And so then if I want to supply 1 here, I'm going to, there's actually sources that we find here, okay? These sources, you can have different types of source that you want or that you may use, okay, in the course of your design. But the 2 main sources that we are going to be using in this is actually the ground, which I've clicked and dragged out, and then we have the VCC, which produces a 5-volt supply, okay, to our system, okay? Now I already have this, okay? So having brought out the sources that we will need for this, this source VCC is going to produce a high for us, and this source is going to produce a 0 for us. So for us to be able to manipulate what the input will be per time, we are going to be using a switch. And how are we going to get a switch? We'll come to this place and we click, we have this switch, okay? So we bring out a switch and then flip it horizontally, okay? Now by default, we are going to set this switch to maybe be at 0. Let me quickly flip it vertically, okay? Now by default, we are going to set this switch to be at 0, okay? Let me just set this to be at 0. Sorry, this is going to be high, yes, and this one is going to be 0, okay? So if you can move this depending on what you want, and then let me bring another switch And if I bring another switch, let me quickly flip this way and flip horizontally also. Okay, now I bring it. Okay, this one again, let's quickly set it to 0. Okay, this one, and then I click this and drag it to connect it to this. And when you click it, you hold your mouse down and drag it to the point. When it makes a circular contact, you leave it and it is connected. So you can click a line and drag it however you want. Okay, so that it will show clarity. Okay, I want to believe that what I have here is visible to every one of you looking at this. Okay, now if I click here, I can connect this and call this one input. Okay, this one input, and I can click here and I connect it here. This another input, and I can now come to this particular switch and right click it and have my component. Now by default, I switch when you press the space bar, you are going to be switching this switch up, on and off. Now let me use A as the key that I want to use to control this particular switch. Okay, so and then this other one, let me change it to B. Okay, now what it means is that in my design I have this as B input, and this is A input. Now if you have your truth table, you are going to have A, B, or B, A, rather, or A, whichever one is your min time and the max time. Now when you now connect this to this, you have the circuit complete. Now as it is by default, I have the two inputs A and B connected to 0, which is ground, and this and this are connected to high. Now if I want to simulate to see the operation of a simple AND gate I have illustrated above, you are going to just click this button right here, and that is the simulation button. When you click it on, you are ready to switch this. So at 0 0, we are having 0. Okay, now if I press A button on my keyboard, you see that the button A has closed, and what it means is that at this input A is 1 where B is still 0, and no output is seen there. Now if I switch this back, okay, if I switch this back and then I switch B on, what I have here is 0 1, and no output is seen on the output or the probe here. Now if I now switch A back, you will notice that there is an output here. You know what we have here is 1 and 1 at this point in time. Now that is the simple operation of an AND gate. Okay, now if I quickly off this and then I want to if I want to remove, okay, rather let me just delete the connection here. Okay, this connection here, I've deleted it. Let me put a NOT gate between. This is a NOT gate. Now the operation of a NOT gate is that whatever you put at the input is going to be inverted at the output. Are we together? Whatever you put at the input is going to be inverted at the output. So if I switch back the simulation again, what we have at the output at this point in time is on, as you can see. But if I switch on the simulation again, this is going to switch off. Okay, so let me switch on the simulation. You see that it is off. Now every other combination that gave us 0 before is going to give us or 1. Okay, every other combination that gave us 0 before is going to give us a 1. Okay, now let me quickly switch A. Now the moment I switch A, this place is supposed to be 0, and because it has passed through this inverting gate, which is the NOT gate, it has switched it on. Okay, now if I switch it back off, we still have 1 1, and the output, this place is supposed to be 1 and the output is 0. Now if I switch B, I'm going to have on here. Okay, remember that when the thing I'm using to control the gates here, or rather the switches here, is the character on my keyboard that I've just done here. Okay, so this is the simple operation of an AND gate, and I've coupled it with a NOT gate. Okay, now I can as well try to couple this one, or yeah, I can as well try to couple this here. And if I am building this circuit this way, what it means is that if I'm building this circuit this way, what it means is that I'm already doing combinational logic design. Okay, where I can move each and every one of these things, mix them together. Now remember that when we talk about sum of products, what are we trying to say? And when we are talking about product of sum, when we are saying sum of product, it means that the output is going to be a summation. And when we are talking about a summation, we're actually talking about an OR gate rather. Now if you are talking about a product of sums, it means that the output is going to be an AND gate. Okay, I'm not here to, this is just a quick primer on how to use this. Now before I conclude this tutorial, let me quickly delete this and let me replace it with these OR gates and see what will happen. We already know and see what will happen. Yeah. Okay, I have this. Let me quickly bring out another probe. Let me see. Don't know how it's going to work, but let me just okay, let me just bring this down and okay. Now this place is an intermediary that shows us what is going to happen when we switch this back and forth. Okay, now if I switch this, okay, we see that at this point, at this point our A is on but our B is off, meaning we have 1 0 here, and the output of the OR gate is giving us 1. So if we pass that 1 into the inverting gate, it's going to give us 0. Okay, now if I also switch on this, what I have is that both of them are off at this point in time. That is when the output of an OR gate gets to off, and then the inversion of this is going to give us 1, as you can see. Okay, this is actually how you can begin to talk about these gates. Okay, now if we want to deal with, let me quickly start afresh to deal with what I call, let me quickly off this, and okay, let's quickly do a combinational logic circuit. Now I have 3 inputs that are A, B, C. Okay, I have 3 inputs A, B, C, and what I am dealing with, I don't know how I'm going to do it now, but let's assume, let me call up my notepad. Okay, I have a notepad here, and I have, yes, let's say A, B, C plus A bar, oh, what am I doing? A bar BC plus A, B, C bar. Okay, so this is what I want us to look at here. Okay, this is what I want us to look at. Let me see if I can paste it here so it can serve. Oh, I'm not able to paste it. Okay, let me quickly reduce this and then bring it up. Okay, look, this is our reference point. The thing we are looking at, we want to build these gates at this point in time, this combinational logic. Now we have ABC, meaning that we have 3 inputs. Okay, 3 inputs. Now these inputs are represented as switches. Okay, now when you look at this, we have 3 inputs, and this is actually the product of sum. This is a product of A, B, C, product of A, but this, and so on and so forth. Okay, what it means now is that in this place I'm going to have AND gates. Okay, and in this place I'm going to have AND gates, and this place I'm going to have AND gates. Okay, and because I have 3 variables there, what I'm going to be having is going to be 3 input AND gates. Okay, now for me to do that, I'm quickly going to bring up an AND gate to the screen. All right, now let me go to the component properties, go to number of inputs, and then make it this way. Okay, I now have 3 inputs AND gates, and let me quickly copy and duplicate it, and I have this, and because I have these 3 already on my screen, these 3 outputs are going to be summed into a summer, which is an OR gate. So I bring forth an OR gate before here. Okay, now because I have 3 inputs entering into this OR gate, I'm going to also look at the component properties and then have 3 inputs OR gates. All right, now I can connect all these together. I'm just telling you how to build these gates here. Okay, I've connected all these together, and quickly I'm going to have a probe in order to indicate when I want an output to be seen on the screen. And for instance, what we have on the screen here shows us that we have an output when these combinations are like this, we have an output Y. Okay, so I have this. Then next is that I'm going to bring out my sources to tell me when I have on and then when I have off. Okay, so I bring out my ground. This is my ground, this is my VCC. So if you hover your mouse over to it, it's going to tell you what output you are working with. So I have my ground, and then if you move to this one, it's going to tell you it's a voltage source, VCC. Okay, now in the first variable that we have here, I'm going to pass ABC to this particular place. Okay, now since I have these input variables, I'm going to be controlling those variables with switches. Okay, now I'm going to come to this place and then bring out switch, and this switch, let me call this one A, say okay, and say flip horizontal. I have this, and then I can copy it and then paste it 2 times on the screen. Now I'm going to edit it. Okay, so this one is going to serve as input B, and this one is going to serve. I'm going to use this to control input B. Okay, and this is going to be input C. Okay, I have this with me now. I've used this to control whether I used switch. I would be using this switch to be controlling whether the thing is on or off. So when you look at our reference point here, what it means that at this first point, all of our switches will be on. Okay, now at this second point, the switch A will be off, while switch B and C will be on. And at this point also, the switch B, A and B will be on, while switch C will be off. That's why I represented it with this apostrophe. Okay, now I'm going to connect it by default for each and every one of these ones to be connected to on. Okay, now let me move this a little bit. Now this, I hope you're following, and then you do the connections as you want it. Okay, now I have my A, so this represents my A, the first product. So what am I going to do is to connect the A input to the first input, connect the B input to the second input, okay, let me quickly shift this so I'll have space. Okay, and then connect the third input to this point. Okay, so already what I have here, is like this. And then I can still connect this to the first one, connect this to the second one, and then I'm going to connect this to the third one. And the same thing I'm going to do here. I'm going to connect this. Let me quickly just connect it to here. And then I'm going to connect this to here, and then I'm going to connect this to this point. So my circuit building is done. Okay, let me delete this. My circuit building is done now. What is happening? It's one of the things you would. Okay, my circuit building is done at this point. So if I want to now control this, I'm going to press A. Okay, so as it is on, every of the output here must be on. Then as this point, if we want to get the output of this one is going to, I'm going to press B to switch this on, and so on and so forth. So I've built this circuit as it is, but we can as well try to use at some certain point invert these outputs. We can as well try to invert this. So if I can move this further, this first one here, I can as well as it is that way, I can as well try to bring out a NOT gate to put it in between. This is still possible. Okay, so and then I now move this to the first one. Okay, so I have at this point, this is going to be north, and then at the last one, at this point again, I can delete this and quickly bring out a NOT gate, place it here, or depending on where I want it. I can now connect this to this place, and then connect C to this place. So I've actually built this circuit. Okay, so I've actually built this circuit. Sorry, I used key. Okay, now this circuit as it is now is giving us an output. Why? Here, when I have switched all of these ones on and these inputs are the way it is, so we have an output here. So as it is here, this is where I'm going to be ending this tutorial. So whatever you are told to build, the thing is for you to look at the configuration, the circuit configuration, and then go ahead to switch, rather to make your connections depending on the number of gates that you have. So what I have here is that I have one gate here, I have another gate here, 2, and then I have the third gate here. Okay, now all of these things are summed into another gate, making it 4, and then this inverting gate made it 5, and an inverting gate here also made it 6. So if I should count the number of gates I used here, I have 1, 2, 3, 4, 5, 6. Okay, so that is it. So with this, we can still use Karnaugh mapping or arithmetic, reduction method to actually reduce these circuits to see what it's going to give us. But that is beyond the scope of this tutorial. The aim of this tutorial is actually to show you how you can easily, or rather how you can use the electronic workbench to run your practicals. Okay, I want to believe that this helps you. If this helped you, please do not forget to share or to subscribe to this channel. Thank you very much.